Okay, so right now, it feels like the entire world is obsessed with AI. And yeah, for good reason. It's changing everything. But you know, while all of our attention is focused on AI, the next massive technological revolution is quietly being built in labs around the world. And that's what we're talking about today, quantum computing.
Look, as mind-blowing as AI is, quantum computing promises to change the game on a level that's, well, it's even more fundamental. It's not just about making our current computers way faster. It's a completely new and honestly kind of weird way of processing reality itself.
So how in the world does this stuff actually work? To get your head around quantum, you pretty much have to forget everything you think you know about how computers work. This isn't about doing things one by one just faster. Nope, it's about doing everything, all at once.
Let's start with the absolute basics. Your laptop, your phone, they all run on bits. A bit is super simple. It can be a 0 or a 1. That's it. Think of a light switch. It's either on or it's off. But a quantum computer uses something called a qubit. And a qubit? Well, a qubit can be a 0, a 1, or somehow both at the exact same time.
This both at the same time thing sounds like magic, right? Well, in the quantum world, it has a name, superposition. And this is the secret sauce. It's what allows a quantum computer to chew on a ridiculous number of possibilities all at once, giving it this almost unimaginable processing power.
To make this real, let's use an analogy. Imagine a giant, super complicated maze. A classical computer, even a supercomputer, would solve it the way you or I would. It would try the first path, hit a dead end, go all the way back to the start, and then try the second path. It's a slow, one-at-a-time process.
Now, a quantum computer, thanks to superposition, it does something that feels like cheating. It explores every single possible path through that maze, the right ones, the wrong ones, all of them at the exact same time. It doesn't find the answer through trial and error, it just sees all the possibilities at once and knows the way out, almost instantly.
Now, okay, before we get too carried away, we have to plant our feet back on the ground. Let's do a quick reality check. We're not living in a full-blown quantum future just yet. We're in the very early, kind of messy, but incredibly exciting first stages.
Right now, we're in what experts call the NISQ era. That stands for Noisy Intermediate Scale Quantum. All that really means is that yes, we have actual quantum computers, but they're still kind of small, they're super fragile, and they're really prone to making errors because of noise from the outside world. So the big challenges today are keeping these super delicate qubits stable, figuring out how to scale up from a few hundred to millions of them, and correcting all those errors that this noise creates. We're making amazing progress, but a true general-purpose quantum machine is still a few years down the road.
But, and this is a huge but, even with those challenges, the potential is just off the charts. The work happening today is laying the groundwork for things that will fundamentally change your life. So let's look at 4 really practical ways this is going to happen.
First up, designing brand new materials. You see, our best classical computers are actually terrible at figuring out how molecules behave down at the quantum level. It's just way too complicated for them. But for a quantum computer, simulating the quantum world is literally what it was born to do. So what does that mean for us? It means we could design new molecules from scratch. Just think about it. Discovering the perfect material for a new EV battery that charges in 5 minutes, or creating solar panels that are twice as efficient. We're going to shift from just finding materials to literally designing them, atom by atom.
Next, let's talk about optimization. So many of the world's most frustrating problems, I'm talking traffic jams, flight delays, supply chain chaos, they're all just insanely complex optimization puzzles. They're so big and have so many moving parts that our current computers just can't keep up. So imagine a quantum computer looking at every single car in a city's traffic grid, or every ship in a global supply chain, all in real time and instantly finding the absolute best route for everything. We're talking shorter commutes, no more out-of-stock signs, and a power grid that doesn't waste so much energy. It's about finding the hidden perfect order in all that chaos.
Okay, this one might be the most important of all. I'm talking about the impact on our health. Our own biology is this system of mind-boggling complexity, and it's all happening at the molecular level. If we can finally understand that, we can cure almost anything.
Quantum computers will finally give us the power to simulate how proteins fold in our bodies, which is a huge deal for understanding diseases like Alzheimer's. We could discover brand new drugs in weeks instead of the decades it takes now. But it's more than that.
It's about moving away from one-size-fits-all medicine to treatments that are designed specifically for your unique biology.
And finally, we have to talk about cybersecurity. This is a big one because quantum computing is a serious double-edged sword. It's both the single biggest threat to our digital world and also maybe our ultimate defense.
Let me just ask you, how safe do you feel about the encryption that protects your bank account, your private messages, basically your entire online life? Right now, it's really secure. But in a quantum future, that all changes. Okay, get ready for this because it's pretty terrifying. To break the standard encryption we use today, our world's best supercomputer would need to run for hundreds of trillions of years. It's basically impossible. A future quantum computer, it could do it in a few hours. That means every password, every financial transaction, every digital secret we have is suddenly at risk.
But here's the other side of that sword. The same weird quantum physics that lets a computer break encryption also lets us build a whole new kind of encryption that is physically impossible to hack. Technologies like quantum key distribution could create perfectly secure communication. So it's a massive race between the quantum code breakers and the quantum code makers.
So you might be thinking, okay, this all sounds like something out of a sci-fi movie that's decades away. And honestly, that was a fair assumption. But the timeline for this whole revolution just got a lot shorter, thanks to a huge breakthrough.
Just recently, in early 2026, scientists announced they may have found the holy grail for building these machines, a material called a triplet superconductor. This isn't just a small step forward, this is a potential game changer for the entire field.
So why is this one material such a big deal? Well, remember that noise problem? The one that makes qubits so unstable? This material could basically solve it. It's also super energy efficient, which is a major problem for today's supercomputers. A discovery like this could slash the time it takes to build a truly powerful quantum computer. So from revolutionizing medicine and materials to fixing our traffic and securing our data, quantum computing isn't just the next step after AI, it's a leap into a totally new way of seeing the world. This revolution isn't decades away. It is being built right now. And the only real question left is, are we ready for it?